Let's go through Lico 698. Partition to K equals some subsets. So it will give us an integer array nums and ask whether it is possible to divide this array into K non-empty subsets whose sums are all equal. So in order each subset have the equal sum, right? So we'll see the total, equal sum. We'll say the totals of this number should be of the array should be divisible by k, right? Otherwise, we can directly return false. So we can so this question is that trying to pick subsets. And what we need is that those kind of subsets, we need to have counts to be k, right? So, and for each subsets, it need to have the sum to be a target value. We look at the range. You'll see the k and then nums length is small equal to 16. So we know those kind of combination style DFS should be able to solve this problem, right? Because for the we don't care about the orders. Combination style is 2 to the power 16 should be doable. So let's think about this question, right? If we do DFS, what kind of parameters we want? Of course, we need how many subsets we already reach the result. For example, if we have the subsets, we use all of these nums and the subsets equals k. Right? Of course, we can return true. And then we also need for current subsets, what is the sum it is, right? And also, for every time we iterate this array, we should have an index. And for this question, because the number can only belong to one subset, it cannot be belong to, for example, multiple subsets. So we have to use some constraints. For example, used, right? Use array to determine if this number is able to select or not. And for this DFS, we should have a return value, that is whether it is partitionable, right? So we are going to let it return to Boolean. So let's write code for this question. I'm going to use, for example, int total equals 0, right? So n equals nums total length. And this is 10 to the power 4, so total int should be enough, right? So what we do is that for int nums, we are going to have total to the plus equal to no, right? So the thing is that we need to have the first corner case trying to see if total mod k down equal to 0, right? We can return false directly. And then we are going to int target. Target equals total divided by k. That is for each subset, we're going to try to reach this target. Oh, that is the sum, right? Sum in every subset sum is the target. For this question, because those combination problem, right? And as we state, right, we need a Boolean whether this kind of integer is used or not, which is a Boolean array, right? And we need let's sort this array because of the combination um or the permutation DFS, sometimes we can use a sorted array that to deduce. That is, if um, nums I equals nums I minus one, and then nums I, the previous one is not being used. In this case, we can escape current one, right? So let's see. Arrays sort sort this kind of nums. As we state our DFS, and we needed to return a Boolean or true or false. We just return DFS nums. Um, we can have a count and a k, right? But for this one, we can just use a k here. Every time we get a subset, we just delete this minus subtract one by k by one, right? And our current sum, and it needs to be equal to target, and we need our index from 0, right? So that means that once this is just once the we get a subset, for example, once we have k minus 1, right? We get one more subset, that is we have one more subset, then our index will start from 0. So in other cases, when we do the index, we DFS from, for example, the next layer should be we passing index should from I from index, and also use so what we need is a private Boolean DFS. We need to have this nums array and int k, right? That is well, how many subsets left, right? So as we state, we use two parameters. Otherwise, we can we just decrease k by one every time we find a subset, and in the current sum, right? And int target and int index and Boolean used. So we'll see here. Actually, we can write, for example, if k equals to 0, return true or false, right? But actually, we can just put k equals 1, right? K equals 0, it should still pass. If k equals 1, if k equals 1, do we need to check all of that are used? K equals 1, do we need to we don't need to care about we can return true directly, right? Because the thing is that the total sum will be target multiplied by k, right? And if it is equals 1, that means for the previous k minus 1, right? We already DFS have k minus 1 subset which have sum equals target, right? So that means this one is target multiplied by k minus 1. So the rest one will of course have a sum to be target, right? So we don't need to write anything. For example, k equals 1 trying to do another DFS that to get the rest of the sums, right? We just return true should be good enough. If you are not confident at this one, you can have write k equals 0. It will also work. We can return true directly. And then what we do is that if current greater equal to target, of course we need to return, right? But there are some kind of scenarios that is current is greater than target. Of course, it is return false. So only return the case return true is return current equals target and EFS nums k minus 1 and the current sum because we found one more sub, subset, right? So this is k we decrease by 1, and then current sum we clear it, restart, so it will be 0, and the target, right? Of course, the index we need to reset as 0 and use, right? So this will be the exit condition. And you have int nums equals nums n equal nums total length. What do we do is that for int I equals, so this is just during the case we are composing in the process of composing subset, right? So 26, that is we find one subset and trying to doing the next. So for here, what we do is for I equals index I smaller than n, I plus plus. So if this nums used is used in any of previous subset, right? We should continue. Of course, we need to dedupe that if I equals greater than 0 and nums I equals nums I minus 1 and nums I minus 1 is not used. We should continue, right? Then we backtrack, used I equals true, used I equals false. So in any case, for example, if we have DFS nums k current plus nums I and target, and we'll see the next index I plus 1 used, then we need to return true, right? And otherwise, in the end, just return false. Current. Okay, doing like this, you'll see because every number it can be select. When we do the DFS, when trying to choose to a current subset, it can be select or not select. So so that it will be a 2 power n possibility. And and for that is 2 power n possibility, and for this k we should have the k, right? Of course, k subset for every subset it has select or not select. So that is k multiplied by 2 power n time complexity. And the space complexity will be O(n). We can also write a Python code for this. So we're going to have, for example, total equals sum nums, right? So I say if the total amount k down equal to 0, you can return false. Then we're going to have a target equals total divided by k. Then we have nums sort. Um, so let's have n equals length nums and used equals false multiplied by n. So return self dot DFS nums k 0 target 0 used. Okay. Then we're going to define DFS self nums. This will be a list of int and k. We need to have k subsets int parent int target int index int used will be a list of 4. So this one will return 40, right? So what do we write? If k equals 1, return true. And then we'll write if we aren't greater than target, then we'll say return aren't equals target and DFS self DFS nums a minus 1. And will reset to be 0 target. Index was reset to be 0 used. Then we'll say we can also we have n, right? N outside. So we can have n here. N plus the length of nums. So for I in range index to n, right? If we use I, we should continue. And let's say if I is greater than 0, and the nums I equals nums I minus 1, and not used I minus 1, right? We also need to continue. So then we backtrack used I equals true, and use I equals false. So I write if self dot DFS nums k and plus nums I target I plus 1 and use if any one of these is true, just return true, right? And at the end, we need to return false. Target sort used return self.dfs nums. If greater equal to, right? Otherwise, will never equal.